Hey there, science fans! Have you ever wondered what holds our cities together? I'm not talking about gravity, although that's pretty important too. I'm talking about cement. This unassuming gray powder is the key ingredient in concrete, the stuff that makes our sidewalks, buildings, and bridges. Without cement, our world would be a very different place. Think about it. The roads we drive on, the schools we learn in, even the homes we live in, all rely on cement. It's the hidden hero of construction, providing strength and durability for countless structures. But how does this seemingly simple powder transform into such a strong and essential material? Let's dive in and uncover the science behind cement. Before we get into the nitty-gritty, let's clear up one common misconception. Cement and concrete are not the same things. Think of it like baking a cake. Cement is like the flour. It's a crucial ingredient, but you can't just eat flour on its own. You need other ingredients to make a cake. Concrete, on the other hand, is the finished cake. It's a mixture of cement, water, and aggregates like sand, gravel, or crushed stone. When these ingredients combine, a chemical reaction occurs, transforming the soupy mixture into solid, strong concrete. So, what exactly is cement anyway? Cement is primarily made up of limestone, clay, and a touch of other materials like iron ore and silica sand. These ingredients are heated to incredibly high temperatures in a giant oven called a kiln. This intense heat causes the ingredients to break down and reform into new compounds, primarily calcium silicates and calcium aluminates. These compounds are then ground into a fine powder and voila! We have cement. Believe it or not, humans have been using cement for thousands of years. The ancient Romans were masters of concrete construction, using a mixture of volcanic ash, lime, and seawater to create durable structures like the Pantheon and the Colosseum, many of which are still standing today. The invention of modern cement, however, is credited to Joseph Aspdin, an English bricklayer. In 1824, Aspdin patented a process for creating cement by burning limestone and clay together. He named his invention Portland cement because the color resembled the stone quarried on the Isle of Portland in England. Section 5. From powder to pavement, how cement hardens. Now, for the really cool part, how does cement go from a powder to a rock-solid material? It all comes down to a chemical reaction called hydration. When cement is mixed with water, those calcium silicates and aluminates we talked about start to react with the water molecules. This reaction produces a gel-like substance that coats the aggregates in the mixture. Over time, this gel crystallizes and hardens, binding the aggregates together and forming the solid mass we know as concrete. Section 6. Built to last, measuring cement strength. Cement strength is measured in pounds per square inch or PSI. The strength of concrete can vary depending on the mix design, but it typically ranges from 3,000 to 5,000 PSI. That's strong enough to support massive structures and withstand incredible forces. To ensure quality, concrete samples are regularly tested to ensure they meet the required strength standards. This rigorous testing helps guarantee the safety and longevity of our concrete structures. Section 7. Rebar to the rescue, reinforcing concrete. While concrete is incredibly strong under compression, being squeezed, it's not as strong under tension, being pulled. That's where rebar comes in. Rebar, short for reinforcing bar, is made of steel and is used to strengthen concrete structures. These steel bars are placed within the concrete before it hardens. As the concrete sets, the rebar becomes embedded within the structure, providing additional tensile strength and preventing cracking. Section 8. Cement, a building block of civilization. From towering skyscrapers to humble sidewalks, cement is an integral part of our built environment. It's a testament to human ingenuity, allowing us to create durable, long-lasting structures that shape our world. So, the next time you walk across a bridge, drive down a highway, or even just step onto a concrete sidewalk, take a moment to appreciate the science and history behind this amazing material. It's the often overlooked foundation of our modern world. Stay curious, science fans.